d-orbitals. So, last video was getting long. Let's discuss d-orbitals and how they are portrayed here in the periodic table. The center section, all the d-orbitals, are a little bit off in how we determine our quantum numbers. Remember that the ordering was we had 1s, 2s, 2p's, then there's some 3s, there's some 3p's, there's some 3d's. Well, unfortunately, this graph of kind of showing the orbitals filling up as we add more and more and more electrons, that we'll have to go to these higher and higher orbitals that have more and more nodes. Well, there's an energy involved in these. Well, the quantum numbers tell us that they should create orbitals in this way, that when n equals 1, you can only have s. When n equals 2, because L has multiple values, you can have s and p. When your n equals 3, your L can have multiple values, and so now you can get out to the d's. That doesn't mean that they fill in that order. The fact that having more nodes means we can have greater shapes and greater complexity does follow that as our n goes up, we get more and more orbitals at higher and higher energy. The d orbitals have 2 planar nodes, so they're higher in energy than the p's that have 1 planar, which are higher in energy than the s, which have no planar. However, as you balance all the nodes and the types of nodes out, well, a 3D has 2 nodes, both of them planar. A 4S has 3 nodes, but all of them are radial. It ends up that 3 radial nodes is actually slightly lower in energy than 2 planars. Because our electrons will go to the lowest energy orbital when they fall onto the atom, the result is that they don't fill all of the n equals 3 before they start filling the n equals 4. The electrons, as they come in, will fill from the bottom up. The 4s, because it is lower in energy than the 3D, it will actually fill before the 3D, and then we will start filling the 3D. The periodic table is designed to show this. As we get past the 3p's, right after argon, the next element is number 19, and it is showing us the 4s's, which is what we see happening right here. But immediately after the 4s, we end up here in our D section. But from looking over at our graph on the side, these are the 3Ds. That first row in the d orbitals, those are actually 3D. The next one down is the 4D. The next one down is the 5D. They are offset from the periods. For our S and our P's, we can just look at, well, which row down. Top row was n equals 1, second row was n equals 2, third row was n equals 4 or 3, fourth row was n equals 4. But if we follow from that over, we run into the 3Ds. Because the periodic table is set up to show how our electrons fill, and the 4s has lower energy than the 3D, we fill the 4s before the 3D. Reality is, if you wanted a periodic table that showed everything just right, you would think that right after the argon, which was our last 3p, we should start having our 3ds. We would think they would just extend past it. The reason they don't is because those 4s's demand that we reset back to the s's and then fill the d's. And so if you want to find the quantum numbers for something like, let's go with gold, AU. Well, first thing first is we would look to the sides and we'd say, hey, how many rows down is that? 5, At first, it looks like it's the 6, but when you get into Ds, it's one less. This is really the 5 Ds. And so gold, Au, the N value is 5, not 6. We would then say, oh, what's the L value? It's in the d orbitals. That's when L equals 2. And so your d orbitals are offset. They still allow you to just look at the periodic table and know what the last orbital an electron went into should be, but the numberings are slightly different than the s and the p's. The s and the p's you can figure out if we were to look at something like lead. Sorry, same row as gold, but over here in the p's, well, lead is definitely a 6. The S and the P's, definitely you just count down. 1, 2, 3, 4, 5. It is 6 rows down, so it is an N equals 6. It's a p orbital, so my L equals 1. The D blocks are always one less than you would think for the row that they're on. The S and P are just whatever row they're on. And so an odd component of the d orbitals, as it has to pertain to the energy that is actually required to put an electron in that shape. If we think about those shapes real quick, a 4s, well, it has 3 radials, so change once, change twice, change 3 times. So remember, your nodes are the change. Here's one change, here's a second, here's the third. So it's not the rings, it's the changes between phase. That is our 4s. Our 3d has 2 planars and is cut plus, minus, plus, minus. The energetics to twist and bend sharp enough to come back and make these 4 lobes is much greater than the kind of gentle waviness that comes from having radial nodes. And so our 4s is just easier shape for the electron to take than our 3d is.